Welcome, everybody. Hope everybody's having a good day. We are coming to you live from our service location in Ogden, Utah. So if you've never been to our training center in Ogden, Utah, here's kind of what the shop looks like. Give everybody a little tour. Really nice shop, good place to work. I was probably close in the top 3 to 5 of my favorite shops that we work out of. But today we are here because and there's Lacey. Say hi, Lacey. Today we are here because we are going to be doing a live propane drop test training and talk about the other items that we would do during our propane test. So got a couple of tools here. These are going to be tools that every technician should own. We'll start with the manometer and kind of talk about what a manometer is, how it works and everything like that. And here's our manometer. This one is going to have 2 readings. Okay. So you have an outside scale here, which is the red. All right. So that's the red. We'll get to make sure it gets some focus, and then the inside scale, which is in the black. Yes.
There's no video. All we can only hear you. We can't see you.
Eric, I was just responding to you. I think it's your computer.
Oh, it's me?
I think it's you. I didn't want to completely say that it's you, but I think it's you. You might
Let me
need to
try
log
again.
off, then back on really quickly, or change your view. All right. Sorry, Ron.
No problem. We're good. So the outside scale is going to be with inches of water column. So it's the red scale. The inside scale is going to be ounces per square inch. And then whenever we're working with RVs, we're going to be using the inches of water column scale. The ounces per square inch is not something we would use because we're looking to have our operating pressure and our everything set at 11 inches of water column. So any questions on kind of how you would read one of these manometers? All right, let me just say something else about manometers. The reason I said that these are a tool that you want is because they are very sensitive. Manometers do come in a bunch of different kind of options. This one happens to be a dial style. We do have water YouTube manometers and straight tube manometers available. The only thing with those is they do require water to be put in them, so they're not quite the best option for your average RV technician. That's why we like these dial styles. Now, the biggest difference to those dial style and the YouTube water style or straight tube water style is that these are not as per se accurate as a YouTube or straight tube manometer, and they're more susceptible to be out of calibration per se. So rule of thumb is that most of the times your shop should have a basic YouTube manometer that you would want to check your dial style against probably at least twice a year, if not at least once a year, to make sure it's within an inch of water column within calibration of that YouTube. And it's very crucial because these are a tool that gets thrown in our toolbox and stuff and slung around a little bit, but they are a very sensitive tool. So you want to make sure it's in good working order. And that's really why it should be a personal tool compared to, say, a shop tool. Because if one of these is a shop tool and per se it does get damaged by somebody in your shop and nobody knows that it got damaged and it's not reading correctly, you would never know, right? So you want to make sure you take good care of these. Now, the other tool I have here, these come in many different configurations, but this is what I would consider, I call it a brass cross testing tool. You can call it really whatever you want. They call it a test device when it comes to RVTI and everything like that. This one is a little bit different than RVTIs. The reason is this has a quick connect on it compared to just a couple of flare fittings on each side. And I would prefer the quick connect over the flare fittings. The reason is if I don't have to ever break a line per se, I don't want to break a line. A majority of our units do come with the quick connects now, and it doesn't require us to break a line, it just requires us to disconnect it. Now, you could say, hey, Ron, what about the actual pressures? Is it affected at these quick connects and stuff like that? Well, the theory used to be that pressure, depending on how far back it was on the unit, can be affected by the distance it is from the propane cylinder. So the rule of thumb used to be connect close to the regulator to get the best readings. But over the years, we've come to kind of change that around a little bit. It tends to be, it's okay, is kind of what I'm getting at. It's okay to hook up the quick disconnect. We don't have to break a line. We can eliminate a step, which includes bubble testing. But if it doesn't come with a quick disconnect, I do want to show you where you would try to connect with this setting, just with flare connections on each side rather than a quick disconnect. So I'm going to take you to the front of this unit. This happens to be just like a StarCraft Superlight. And you're going to want to go to right to your regulator. All right. What we do is we have a 2-stage regulator here. And the first stage knocks the pressure down to about 10 PSI. The second stage knocks that pressure down to our working pressure of 11 inches of water column while 50% of the load is running. So what does that mean, 50% of the load? Well, our regulators are rated at 200,000 BTUs per hour. So half of that is about 100,000 BTUs per hour. Now, how do we test that to make sure we're at 11 inches of water column while we are testing it? Well, on our test device, I'm going to run back over here. We have an orifice drilled into this test device. This orifice right here simulates approximately 100,000 BTUs per hour worth of propane flowing to it. So basically, when we're making an adjustment to the regulator, we open that ball valve to the orifice, and then we can adjust the regulator right there. We'll pull this cap off, okay? And then clockwise will increase the pressure, counterclockwise will decrease the pressure, all right? So really, if we do connect here, and this is where we would connect, all right, we'll just pull that connection off right there and put that piece in line, and this is where we would attach. The only extra step that you'd have to do is a bubble test on this if you were to take this apart. So what we're going to do is we're going to hook this all up to begin with. All right. So I'm going to take my tools here. Sorry, I covered the camera though. Take my tools here. We're going to find our quick disconnect. On this one, it is directly in the back. Okay. On these quick disconnects, it's a couple things you need to think about. They do come with a cap. These caps should be installed whenever it's being traveled. And then there's an on-off valve right there. So what we'll do is we'll take the cap off and we will connect that portion right there. And then we will connect our manometer directly to this barb fitting right here. Lacey's going to hold this camera for me while I grow an extra arm. So we're going to connect there. Okay. And then we're going to turn this on. Now you'll notice it didn't jump up at all because I have an extra ball valve here. So what I'll do is I'll open this ball valve and it will peak up for me. Okay. And that's okay. It may peak up above 14. The reason is there's a lot of pressure sitting here. Now, there is a rule that we have what's called a maximum lockup of 14 inches of water column. Now, I'll show you really how to do that. A lot of people freak out if it goes above 14 when you first open this ball valve. It's okay if it does. I'll show you how to test it when we get there. All right. I'm going to take this back and you can see we did peak. We did have propane in the lines, but it's actually not on. So once I have that connected, I am going to go up front again, turn my propane cylinders on. All right. So I can make sure I'm pointed directly to the cylinder I want to use, and that's this left one. I'm going to turn the propane cylinder all the way on. And whenever you open up a propane cylinder, it's all the way on or all the way off. There's a packing or a wadding in here that is designed to go against that stem to make sure we don't bleed back. So we want to make sure it's all the way open or all the way closed. Now, a couple of more things that I'll say before we move back there is this is an auto changeover regulator. The way this is designed is this is for a dual cylinder assembly. There are two springs in here in the top, and in that 2 springs we have a diaphragm. And basically how this works is when we have deliverable propane and it's manually selected here, okay, it automatically depresses that spring and diaphragm so that way we feed directly from this cylinder. If this cylinder becomes void of propane, or as in it's empty, that diaphragm cannot be pushed against, so it will push this side in what we would call lockup mode, and it will automatically start feeding from this side as long as we have this cylinder on, right? And then vice versa if you were to have it pushed on. But the way we feed from a main cylinder is by manually depressing that diaphragm with this dial. So you see here, this is manually depressing towards this tank. If I were to flip this, it would be manually depressing that towards this tank. And that's how it works. Now, a lot of people think that if you put it in the center, it's going to drag down evenly. That is not the way it necessarily works. The reason is it will always take the one with the more pressure in it. Now, can you look at that as evenly. In an aspect you could, but it's going to do this thing, and I'll have Lacey come back over here for 1 second. I'll kind of give you a visual. All right. If I were to leave that in the center, depending on the amount, take a look right here, depending on the amount or the level of propane in that, if we were to have it in the center like this, not manually depressing one of those diaphragms, and say that left tank had a little bit more deliverable propane in it than the right, it would drag that one down, right? And then just a little bit drop less than this one, and then it would switch off and just kind of do this. Where it could be evenly, you could think of it that way. It's not pulling both at the same time, right? It's kind of staggering it because at one point, this one may have more deliverable propane and pressure wise in it. And then the other point, this one may be. So it's kind of competing for how much pressure it is. That's why I don't like to really think about it as evenly, because it's not pulling directly evenly from both at all the time. Okay. But yeah, you always want to be pointed towards one thing. Now, when it comes to technician explaining that to customers, okay, you can explain it in a couple of different ways. It doesn't much matter to me. Some technicians will explain it, open both cylinders, all right, choose your tank. And when that one becomes void of propane, it will automatically start pulling from that one. Other technicians like to keep one of these cylinders closed. So that way, if a customer isn't necessarily really paying attention to how much propane they have, and say they, didn't show up with both full cylinders for a weekend trip, and they make this one void, they have an opportunity to come open this one and understand. It doesn't matter to me which one. I know, preferably if it was my unit, I know how much propane I'm going into the weekend with, and I'm opening both of them. So if at 3 a.m. I do run out of propane for, say, my furnace, I don't have to get up and run outside in the middle of the night to turn on my other cylinder and everything like that. It's totally a preference customer wise. And as a technician, you can decide to explain it to a customer how you would like. Does that make sense to everybody? The way I kind of said that. Is there any questions on that? No? Good? Okay, perfect. All right, so I turned that propane cylinder on. And then I turned it back off. Okay, I did turn it back off, right? I didn't start talking and leave it on. Let's double check. But you would turn it on, all right, get the deliverable propane to the back, turn them off. See, I didn't turn them off because I got talking, my bad. Turn them both off. All right, they're both off there. Then I'm going to go to the back, and this is where it kind of gets funny. Sometimes you can overshoot this, so you want to be gentle with it. But what I'm going to do, as I mentioned to you, I had that orifice here on the side and this ball valve right here. What I'm going to do is I'm going to open this ball valve and drop the pressure. So you see, I'm going to open the ball valve slightly and drop the pressure down to 8 inches of water column. Let's see if I can do this by looking and holding the camera. So it can happen quick if it's a smaller unit too, because there's a lot less lines. So we're just going to, hopefully I don't overshoot it. Oh, we're getting there. That's 9. That 8. Where? Right there. Okay. That's 8 inches of water column. Once I've reached 8 inches of water column, I'm going to let it sit for 3 minutes. Okay. It is a minimum of 3 minutes. And the reason we have to drop that pressure down is because of, right? So everybody understands we got to leave that set for 3 minutes. But the reason we have to drop that pressure down is because we had pressure sitting in this first stage of the regulator, and then also propane pressure sitting in these pigtails, which is full cylinder pressure. We want to get that all purged down to leave a nominal amount of pressure in those lines. So that way, if we do have a leak, we find it very quickly. If we were to leave that full pressure in there, both in that first stage of the regulator and also in those pigtails, it could take 15, 20, possibly even longer amount of time to see if there was a leak. And we are all about efficiency in this industry, so we want to make sure that we're trying to make this as quick as possible. Now, I jumped up a little bit in that 30 seconds that I was gone, so I'm going to drop it back down to 8. All right, just to make sure, because you will get sometimes what's called creep. And what creep is if you have a temperature fluctuation between the propane and the propane lines. Say you were outside and it's cold a lot of places right now, and your dispensing facility was outside, obviously it's going to be outside, but your dispensing facility was outside and your propane was cold and it was dispensed, and you brought your propane cylinders into a nice warm unit that, say, was sitting inside in your facility overnight, your lines will be warm. Okay. And what happens with propane, every 10 degrees Fahrenheit that propane is warmed, it expands 1.5% its original volume. So as you're feeding that cold outside temperature propane into warm indoor temperature lines, it will bump up. And that's why we call it creep. So make sure your lines and your propane are equalized. Now, this unit's been in for 24 hours and we had a little creep up, so we just dropped it down a little bit. But that's the basic understanding of why you might have creep. All right. So I'm not timing it, but I did look at my watch before I started, and it was 12:48. So we'll give it to 12:52 just to make sure I wasn't on the end of 12:48, and then we'll go back and check it. While we're waiting for that 3 minutes to pass by, is there any questions that anybody had about propane in general? It doesn't matter to me whether it has to do, I'm going to flip my camera here, whether it has to do with an actual drop test or about propane cylinders or propane tanks. If nobody's got any questions, I'm going to throw a trivia question while we're waiting for the 3 minutes to go out there. Anybody? Questions? All right, here's my trivia question for you. How often do ASME tanks need to be recertified? So I'm going to throw it in the chat, or you can unmute yourself. So ASME tanks, if you're
Hold
not
on.
sure,
Don't
ASME,
give them.
okay.
Don't give them the answer yet. Somebody on this call
was
knows
given.
the answer. Troy says 10 years. Michael says 10 years. All right, Ron, go ahead and answer.
All right. It's a
Never.
trick question, everybody.
Never.
ASME tanks are the type of tanks that we mount on motorhomes, and they do not need to be recertified. While they do need to be in good condition, you need to appropriately check them on a PDI and make sure they don't have leaks. They don't need to be recertified as our DOT cylinders would. Our DOT cylinders, hold on, let me flip you back around. Now, these are our DOT cylinders. Okay, these are our removable cylinders that we'll use on travel trailers and fifth wheels. They do have a 10-year expiration date. Now you can see here, as long as it's clear, this one was manufactured in 10 of 23. Is that 23? Yes, 23. So this would need to be recertified by an appropriate facility in 2033. So they do have a 10-year. All right. But our ASME tanks on our motorized that are mounted to the frames and stuff like that do not have an expiration date. But as an RV technician, you should be going through those to make sure they're in good condition, don't have major dents or flaws or anything like that. All right. So kind of a trick question. Didn't mean to trick everybody, but I figured it was something fun to talk about while we waited for the 3 minutes to pass by. All right, it's 12:52. We're going to run back. We're going to take a look at our manometer. We take a look here. Flip my camera around. See if you can get it. All right. And we didn't drop any pressure over that 3 minutes. We're sitting there. It might have creeped up just a little bit, which is all right that it creeped up a little bit. If we had a leak, it would show very quickly. If you have a lot of creep where it creeped up down up to 11 or 10 and a half, you may have to do something. Sorry, I was pointing in the wrong direction. You may have to take a look at what's going on with that. The reason is you could have an issue with a bad service valve on your propane cylinder, or something else going on, something leaking by. So yeah, you definitely want to make sure that if you have a lot of creep and your propane was equivalent temperatures to your lines, that you take a look at that. But I know that we just had a little bit, it just jumped up a little bit. It's okay. But if you have any drop at all from that 8, that deems that there is a leak somewhere in the system. What do you do from there? Anybody want to take a stab at where you might start if you had a leak? Where the best place to possibly start with if you had a leak on a system or a drop from the 8? Where would you start? I'll give you all a hint.
The regulator and the hose connections, the pigtails.
Yeah, start at the pigtails. Look at the regulator first, and what you're going to do is you're going to take a soapy solution. You're going to spray all these connections down with the propane cylinders on. Okay. You're looking for any leaks there. Okay. Because it can very quickly be lost. All right. Kind of here, here, here. Okay. Now these pigtails and the end of these pigtails, they do have check valves, backflow check valves. So we don't send anything through this way. But you could still have leaks here and here and here, and it would show up on your regulators. Now it's a little tougher. Some of these regulators can have some additional features in them that may make it harder to see leaks here. But for the most part, you will see that there. And just take a non-corrosive. I say non-corrosive bubble solution. What do I mean by non-corrosive? Well, non-corrosive, it shouldn't contain any chlorine or ammonia. Okay. And then somebody put something in the chat. I wasn't able to catch it. What did it say? Or Lacey, what did the chat say?
Sorry, I was unmuting. Sage says, make sure everything is off inside the trailer. I had a trailer that had a stove burner on from factory that was making me think I had a leak.
Absolutely. That's a great point. Yeah. So you know that we are at all of our dealerships across the country. Okay. A lot of this is experiences for families, right? And what are you going to do when you come look at RVs? You're going to bring your kids. I would bring my kids when I was looking for an RV. Hey, you want their input too. But you know dang well those kids are in there playing with the knobs and buttons and everything like that, and they turn a stovetop burner on. It's very common to happen. So yeah, so make sure that your stove burners are off. Anything like that isn't on, because that will make it look like you do have a leak. All right. Now, was there any questions on the actual drop test? Because we got 2 more things to do. But that is a great point, whoever wrote that in there. Yeah, absolutely. And then you would work your way back too, if you couldn't find it right there. All right. To connections, I like to check all of the back of my appliance connections. So whether I make the connection at my, say my furnace or my stove, or if my water heater, check all those type of connections. Underneath, you're going to have, a lot of the times you're going to have like aluminum manifolds that you can check, like those connections, or you'll have unions in your black iron piping for your manifold. Check those. Those can leak sometimes too. You can actually have cracks in some of those. But was there any questions on doing the drop test? Because we're going to talk about the next 2 tests. No? Okay. Once we've confirmed our drop test and we don't have a leak, we're going to go ahead and turn our propane cylinder or tank back on if it's a motorized unit. So we're going to turn it on. Okay. And then we're going to go back to the regulator, and we're going to do what's called an operating pressure test. The longest part of this is walking back and forth. So once we come back, all right, again, it's going to peak. What we're going to do is we are going to open this orifice valve that I talked to you about. All right, we're going to open this orifice valve, and we're looking for 11 inches of water column to be running. So if you take a look, I got it opened there. Oh, flip my camera. And if you see there, I got 11 inches of water column. With that running, that should be at 11. If that orifice valve is open and say it's lower, maybe to 10 or a little higher to 11 and a half or 12, you're going to want to go ahead up to the regulator. Okay. And sometimes this can be easier with a, buddy, hey, I got to make an adjustment on this regulator. Can you watch my manometer? You'll pull this cap off right here. See if I can get it. I may need tools. Nope, I got it with hands. Okay. This one happens to be at 11, but I want to show everybody what it looks like. Sneak everybody down here if you can see it. Okay. And you will see there a little hex nut in there. See that hex nut? You can throw a little socket on there, and clockwise will turn the pressure up. Counterclockwise will turn the pressure down. They are very sensitive though. All right. And basically what you're doing there is you are twisting that, and it's threading itself in, and it's pressing against a spring that is pressed against the diaphragm. That diaphragm is what allows either less or more pressure to flow through it. So when you do it clockwise, you press against that diaphragm. Therefore, it takes more pressure to press against that diaphragm to close it off. That's why that's making the adjustment. It's allowing the pressure flow to change. Okay. So that's the adjustment. Any questions on the operating pressure test? That's the next piece of it. Okay. Here's my next question for everybody. Let's see who can get it first. My next question is what temperature does propane boil at?
Negative 44.
Absolutely. Negative 44. Now, what does that mean? It's a weird temperature for something to boil at, right? Especially because we always think of water boiling at 212 degrees Fahrenheit, which is a hot temperature, right? We have to heat it up on a stove. All right. Well, propane, all right, the consistency of it, make sure that it boils at every temperature above negative 44 degrees Fahrenheit. So if it's 12 degrees Fahrenheit, it boils. If it's 55 degrees Fahrenheit, it boils. If it's 85 degrees Fahrenheit, it boils. If it's 100 degrees outside, like it is in Texas in the dead of summer, it boils. It boils at everything above that temperature. And above that temperature, too, it tends to boil better. And the reason I say that is because when you get down into colder temperatures, get down into your 32 degrees or freezing temperatures, it can have a hard time. The reason it can have a harder time is because it needs to absorb that heat to boil. All right. And if you have a propane cylinder and have it say low, the pressure's low, look at that surface area. The only surface area that it can touch to boil that propane is very little. All right. So how to solve that if you're trying to use propane in colder temperatures is at least have your cylinder 50% full. Okay. Therefore, you have more surface area for it to basically be what's called wetted and boil. Okay. And it can boil better and create the amount of BTUs you need to run these appliances. I think somebody just mentioned it. I think they said the rate of vaporization. Yes, the rate of vaporization will change too in those temperatures. That's great. I don't know who said it, but yeah, absolutely. It lowers as you get into colder temperatures, right? And that's perfect. So that's a little fun fact, and that's kind of the reason I bring it up. Any questions on that? All right, the last thing we're going to do, it's called a lockup test. Okay. And what the lockup test does is the lockup test makes sure that our regulator is closing up before it gets to a certain inches of water column. Now, how do I do it? I said that it was 14, right? This is fun. Okay. I said it was 14. Here's how I'm going to do it. I'm going to quick open this orifice valve and I'm going to quick close it. That's all I'm going to do. And then I'm going to look at my manometer. And I'm going to make sure my manometer doesn't go above 14 inches of water column. Okay. This one did. Technically, this is a failed regulator. This would need to be replaced. It cannot lock up at anything above 14 inches of water column. Now, I would take and I would retest this on a different manometer before I made that decision. But according to this manometer, this would be a failed lockup test. Okay. Cannot lock up at anything above 14. Technically, it's sitting at 14 and a half. Okay. I would replace that regulator if this was a brand new unit under warranty. All right. I'm going to retest this one with a different manometer to make sure I don't have a problem with this manometer. But does anybody have any questions about lockup?
Just going over that quickly, Ron. So the complaint would be that what would the complaint be, the cause, and then like your correction just quickly?
The complaint would be that this unit failed the lockup test, and the lockup, according to our NFPA 1192, which is our codes and standards for manufacturing and everything and propane when it comes to these RVs, is that our regulators cannot lock up above that because the pressure is too high, which can cause issues down the line. We actually went through a recall about a half a decade ago, 5 years ago, where we replaced a bunch of regulators because they failed lockup. They were above the 14. And it presents a safety issue is basically how they structure and word it. All right. You don't want it above that 14. And adjusting the regulator isn't going to change that. All right. The adjustment of the regulator is at that 11 inches. So you're going to want to make sure that you do your due diligence and write it up as failed lockup. Right. Doing my propane test on unit, failed the lockup test. Did the drop test, drop test was good. No leaks in the system. Performed the operating pressure test, 11 inches of water column while running 50% of the load. And then our lockup, when I closed the orifice valve after completing the lockup test, it peaked above 14 and went to 14 and a half or 15. And we will need to replace the regulator on the unit and however much time you're requesting to do so. Now, kindly, somebody brought me over another one, so we're going to test it real quick. We're going to shut it off, see if it was the manometer or not. Give me 1 second. Lacey's going to come hold this camera here for a second, and I'm going to switch over these manometers just to double check.
So while you're doing
'Cause I
that,
can-
is it always recommended that you double check? Like if you don't have another manometer, should you at least run it again, or do you always go with your first reading?
I would run it again. This one I'm going to run again. The reason is this might be an older manometer. Like I said, with manometers, they are very sensitive. It just might be a little funny, might be out of calibration. So you always want to double check. I don't always just take my first inkling when it comes to these tests. And reason is like I said, you could drop the manometer, it could take it out of calibration. It hasn't been calibrated in a little while. Could be a little bit out of whack. Just take your time, do it again, do the test again is the best solution. So it did peak up above to 15. I'm going to shut it off or open it up. Yeah, see, this one technically fails. It is 14 and a half. So there's nothing wrong with this manometer. I would fail this regulator and write it up for replacement. So, all right, and that's with two. You could even throw in there that you use two different manometers to double check, but technically that is a failed regulator according to our codes and standards. So, yeah, write it up and submit it. Any questions on that? I'll flip my camera around here. Maybe. But those are your tests. The only thing that I didn't talk about would be if you did connect in between the regulator and the connection, you'd have to obviously disconnect that and spray the solution on to make sure it didn't leak because you connected it. But yeah, that's your propane test in a nutshell.
Ron, I might have missed this. The pigtails, aren't there like a date range on those things where they have to be replaced?
Some of that's a tricky question to answer, David. There are a lot of places that do have dates on these. I don't want to automatically say that these pigtails are out of date. I would visually inspect them and see if they are cracking. And if they are cracking, then I would approach it that way. Some people throw a 10-year lifespan on these pigtails. If your store decides to do something like that, you'd have to reach out to your market, all right? Because not every store is going to do something like that. So if you have questions about that, I would say it's per market right now is how I would handle that. But
Okay.
the pigtails themselves, they would be considered an assembly. Do they have an expiration date per se? No. Just like the rubber hoses that you would have that connect after that. No, but I've heard a lot. But I will say this about propane. In propane things that we have in RVs. Our LP detectors do have an expiration date. You should really think about that kind of stuff. Okay.
Thank you.
That's a good question, Dave. I know that comes up a lot, but technically, like Ron said, they don't actually have a true expiration date. There's a lifeline or a service lifeline that they say. Some are 5 years, some are 8 years, some are 10 years. So really, we just want to make sure that we're inspecting them, making sure that they're in good condition. And if there's ever any doubt, then I would say you need to replace them.
That's exactly it. Yeah. If you do, though, I will say this about pigtails. These are, I'm going to flip everybody's camera again. Oh, can everybody see? These are not repairable in any facet. If you have a damaged line here, you cannot put anything in line with a couple of worm gear clamps or anything like that. They need to be replaced as a whole component. These have special crimps on them. I say special, but they are crimped by a manufacturer who's authorized to do so to allow full cylinder pressures and tank pressures to be fed through them. You cannot throw inside any of these manufactured lines. You cannot repair these rubber lines. They need to be replaced as a whole component. When it comes to copper lines can be repaired. If you need to reflare anything like that, you can do so. But when it comes to these rubber lines, they're replaced as a whole component. Now, technically, there is a rule. These lines, these rubber lines, are only supposed to be a maximum length of 60 inches before they have some sort of connection. I'm going to say that's all manufacturers abide by that rule. There's a fine line that's drawn there also. I've seen lines longer than 60 inches. They make lines longer than 60 inches, but that is supposed to be the rule to our codes and standards. So propane is a funny thing, everybody. It's a very flammable fuel. We use it pretty much on all our RVs. Obviously this is a travel trailer. There's very few RVs that don't have it. All electric coaches like this one over here. This one doesn't have any propane, but I'd say a majority of the stuff that we deal with is going to have propane on it. So we want to do our due diligence, do all these tests to make sure everybody's safe. Because if we have a propane leak in any fashion, and it is able to get ignited by some sort of either flame or sparking source or anything like that, thermal events happen very quick. It's kind of what I'm trying to get at. So make sure you do your due diligence. And every time you either start a PDI or are working with propane, you do the drop test first and foremost to make sure there's no issues with leaks or anything of that nature. Okay.
Awesome. Thank you. Are there any questions, comments, anything else before we let you all go for this afternoon?
Hey, Ron, this is Dave. Just a quick
Yes.
question. I know you've been doing this for about 50 minutes now or something like that. How long does it take a tech to do this just nonstop without pausing camera, doing all adjusting? What's realistic time frame for an average tech, not someone who's been doing it for 50 years, just someone average tech?
5 minutes. It literally takes 5 minutes to do this test from front to back. And I'll give you 6 minutes if you have to break that line up there at the regulator to slide in that little brass cross. But it literally takes 5 minutes to do these tests. That's why it's super imperative that it's done at the time of PDI to make sure everybody's safe in these. No leaks, nothing's going to happen. It doesn't take long. It's 3 minutes for the drop test. It's literally 20 seconds to check the operating pressure. If you have to make an adjustment, that's something you get paid for. If you have to make an adjustment, submit it for warranty. The adjustment does not count for doing the test. It is an additional thing. If you had to make an adjustment, it's because there's some sort of, it wasn't adjusted properly for the manufacturer didn't check it, anything like that. If it failed the lockup test, that's additional time too. That's the replacement of a regulator, whatever flat rate is happens to be on that. But to do the test, it's 5 minutes.
Okay, so for guys like me and Dave Lash, it's probably 15 minutes. All right, good.
No, we can get you to do it in
You
5
give me,
too, I
you
promise.
give me 5 minutes?
Absolutely, 100%. I spend 10 minutes with you teaching you how to do it the first time. You'll be able to do it in 5 minutes every time.
Yeah, Dave Lash should still be 15, but okay, good. That's what I need to know. Thanks, Ron.
Yeah,
For
absolutely.
sure. Hey, Ron,
Fantastic.
are the digital manometers better than the analog? You might have covered that. I'm
Okay.
sorry.
I didn't cover that, and I don't generally talk about digital manometers. The reason I don't talk about digital manometers is that if you purchase one, generally they have to be a decent quality digital manometer. They do carry a price tag with that. If you get one of the cheaper ones that you see on Amazon, they tend to not read properly overall. And if they do fall out of calibration in any fashion, you cannot calibrate those and try to fix them like you would be able to do a lot of our dial style, which have a little flathead screwdriver you can do to adjust it in relation to your YouTube. So I try to avoid those digital ones and stick with our basic technology, which is our dial style and everything. But that is a good question because everybody likes it. We live in a digital age and everybody likes digital technology. But if it falls out of calibration, technicians can't fix those. They have to send them back to the manufacturer and probably pay for them to be recalibrated and everything like that. It's not something I find to be worth it. That's just my opinion. You'll find other technicians that love their digital manometers, but those are the reasons I have to back my decision.
Thank you.
Anybody else? All right. Well, I appreciate everybody joining. I hope you took a few pieces away. If you didn't know all this stuff, if you didn't know any of it, I hope you got it all. If you have any questions, feel free to reach out to the training team. We'll get you anything you need. I appreciate everybody joining. Have a great day, everybody.
Great job,
Bye,
Ron.
Ron.
Thank you.
Thanks, guys.
Thank you. Bye, everybody.